Hey there, class. Mr. Posky here. We are continuing with Chapter 5, which is about quadratic functions and equations. Today we're doing 5.3, which is square roots. And it's actually going to be broken up into 2 days, I believe, or 2 videos for this section. So, yeah, we'll get right into it. Here we go. So, this symbol, a radical sign, that's an operation. So when you square something, when you do x squared, that means multiply it by itself, right? The square root is called the inverse function, which means you're doing the opposite. So if you take 3 squared, you're multiplying 3 times 3, which equals 9. You're taking the square root, it's saying what number, or square root of 9, it's saying what number squared equals 9. That's what it's saying, right? And so, because it's an operation, it needs to have one result, okay? When you take the square, like if you did 4 minus 3, that has to equal one number, which is 1, right? So, when you're taking the square root of something, it's going to mean it's the positive square root. It's going to mean it's the positive square root, okay? So, even though what happens is, if we have, for example, what number squared equal 9? So 3 times 3 squared equals 9. What else equals 9 when we square a number? Well, we also have negative 3 squared, right? That also equals 9. But when you're doing, when you're taking the radical or taking the square root of something, it automatically means take the positive number, which is going to be positive 3 for this one, okay? So what we do to get around that, if we're doing the square root of 9, if we have x squared equals 9, we take the square root of both sides, what we would do is we would x equals positive or negative 3. That would cover both results here. Sorry, my nose is a little runny. Okay, so it says the square root of n equals r if r squared equals n. So, for example, we have the square root of 36 is going to just equal 6. So, 6 squared equals 36. And n is going to be called the radicand. Say radicand. Say radicand one more time. All right, sounds good. So, let's get into properties of square roots where a is greater than or equal to 0 and b is greater than or equal to 0. So let's go ahead and change the color here. So the product property, if we have the square root of a product, it equals the product of its square roots. Well, what does that really mean? Basically, what it means is we have a square root of a number that's a product of 2 numbers. We can break it down into smaller square roots. So, for example, if we have the square root of 125, well, what multiplies to 125? We can take any factors we want. Let's take a couple that are going to make it nice here. Well, 125 can be broken down into 25 times 5, right? Well, that's pretty nice. And why is that nice? Well, the way we simplify radicals, this whole part of the section we're going to be covering is about simplifying expressions and radicals. When you simplify radicals, it means you pull out all the perfect squares. So, for example, if you had, like square root of 16, or square root of 81, that equals 9, this equals 4. If we pull those numbers out, that's going to be how we simplify. We pull out all the biggest numbers that are perfect squares, basically. Okay, that's what it means to simplify a radical. It means there's no radicals in the denominator, and also there's all the perfect squares have been factored out or pulled out in front. Okay, so what does this mean? Well, we have square root of 25 times 5. Well, that can be broken down into 2 different square roots. The square root of 25 times square root of 5, right? Well, what is the square root of 25 going to be? Well, that's going to be 5 square root of 5. Okay? So, simplifying radicals, in the radical, you want to look inside here and see if there's any perfect squares that go into that number, and then you're going to pull those out in front. So, for example, if we had square root of 20, that would be square root of what number is going to 20? Well, we have 2 times 10, we have 1 times 20, we have 4 times 5. Well, 4 is a perfect square, so we're going to pull out a 4. Square root of 4, which is going to be 2. We'll do this here. We'll have square root of 4 times square root of 5, which equals 2 square root of 5. Okay? So if you can find any perfect squares that go into a square root, that's going to be what you're going to want to pull out, because that's what it means to simplify a radical, is to pull out perfect squares. Okay, next one, quotient property. The square root of a quotient is the quotient of two square roots. All right, what does that mean? Well, if we have, for example, we have big square root of 9 over 16. When you're simplifying something like this, you want to see first if you can simplify this like by dividing, first of all. Okay, well, does 9 divide by 16 or no? 9 does not divide by 16. So, sorry about that. So 9 does not divide by 16, so we're going to split this up. We're going to split it up into two different square roots. We're going to split up the square root of 9 divided by square root of 16. And why is that nice? Well, those are both perfect squares, so what's the square root of 9 going to be? Well, that's going to be 3, and the square root of 16 is going to be 4. And that's our simplified answer there. Okay? So, we have some examples here. Why don't you guys try, just see if you can do like numbers, 1 through 5. See if you can figure them out. Give them a try, but we're going to go through them after you pause the video, okay? All right, let's do number 1. We have square root of 75. Okay, so we need factors of 75. We need to split this down into smaller factors. What multiplies to 75? Well, 75 is going to split down into, we have 25 goes into 75, which is a perfect square. So you could divide by 4, divide by 16, divide by 25. And then if you find a perfect square that goes into that number, that's what you're going to want to use. So we're going to write this as going to be equal to square root of 25. And 25 times 3 is 75, which equals, now I can split it into two smaller square roots by the product property. What's the square root of 25 going to be? Well, that's 5, and then we have square root of 3. And 3 doesn't have it. 3 is a prime number, so our final answer is going to be 5 square root of 3. Okay. All right, number 12, or number 2. There's a 12 in number 2. We have 3 square root of 5 times square root of 12. Okay. One thing you need to know about multiplying these kind of things is you can only multiply radicals together and whole numbers together when you're multiplying. We have to kind of do some kind of, they're kind of like, it's kind of like terms, kind of, but not really, I guess. So we're going to multiply the radicals together and the whole numbers together. Well, we have square root of 5 times square root of 12. So we have 3 times 5 times 12 is 60. So we get square root of 60. That's the reverse of the product property, where we can combine into a bigger square root. Now what we need... Now we have 3 square root of 60. We need a perfect square that goes into 60. What number goes into 60 that's a perfect square? Well, does 4 go into 60? It does. Let's try 4. You could also, if that doesn't work, you would try 9, then 16, then 25, then 36, then 49. But you actually would stop at halfway up to 60 because it can't be bigger than half of 60, basically, okay? So we're going to write this as square root of 4 times 15. Now we can split that into two smaller square roots. So we got 3 square root of 4 times square root of 15. And 3 times square root of 4. Square root of 4 is 2. And we get 3 times 2 is going to be 6. And we get 6 square root of 15. So if you're going to plug both these into your calculator, this and this, they'd be the exact same thing. It's just simplified, basically. Okay? And this is 6 times square root of 15. You can have whole numbers in front. It's just you just can't combine them because they're not, this is a whole number, this is a radical, but that'd be your final answer, okay? All right, number 3, we have 5 square root of 2 times 6 square root of 8. All right, we got to multiply the whole numbers and the radicals. We got these are going to go together and these are going to go together. So we have 5 times 6 is 30. We have square root of 2 times 8 is going to be 16. Well, that's really nice because square root of 16 is just what? Square root of 16 is 4, and 30 times 4 equals 120. There we go. All right. All right, we got number 4. We got square root of 4 over 25. And does 4 divide by 25 nicely, or no? It actually doesn't, so we would actually need to split this one up. That's actually going to make it a lot nicer. You'll see in a second why. We have square root of 4 over square root of 25. Well, that is just two perfect squares. The square root of 4 is just 2. Square root of 25 is 5. And there's your answer. All right. Number 5, we have square root of 50 over 9. Does 50 divide by 9 nicely? It does not. So we're going to write this into two smaller square roots. We're going to write square root of 50 on top over square root of 9 on the bottom using the quotient property. We can split up 50 because 50 is not a perfect square. So what is our perfect square that goes into 50 that we can use? Well, 25 times 2 is 50, so we can use 25 because 25 is a perfect square. Okay, now we can simplify this. Square root of 25 is just 5. Square root of 2 we can't do anything with. There's no perfect squares that go into 2. And square root of 9 is going to be 3. All right, and then number 6. We have square root of 3 over 5. Okay, well this one, does 3 divide by 5 nicely or no? It does not, so we need to split it up into square root of 3 over square root of 5. But we can't do anything with square root of 3 over square root of 5. We actually could leave it just like this, except there's a problem. What we need to write over here in this box is we can't have a square root in the denominator. You can't have a square root in the denominator, and mathematicians do not like that. So we came up with a trick for fixing this, and it's called rationalizing a denominator. And so all you need to do to rationalize a denominator, all you need to do to rationalize the denominator is to multiply both top and bottom by the square root in the denominator. So we're going to multiply both top and bottom by square root of 5. And why can we do that? Well, what's the square root of 5 divided by the square root of 5 going to be? This just equals 1, right? That just equals 1. So we're not actually changing the problem by multiplying by 1. But it's going to help us kind of simplify the problem here. So square root of 3 times square root of 5 on top is going to be square root of 15. And then square root of 5 divided by square root of 5 is going to be square root of 25. But why does that help us? Well, what's the square root of 25 going to be? That's going to be 5. So it's square root of 15 over 5. And that's all we're going to do in this video. So our square root of 15 over 5 is our final answer. Thank you for watching. Have a great day. We will see you soon.